Find the volume of the parallelepiped generated by the vectors u, v, and w in R3. So if we have two vectors, then they can generate a parallelogram. And when you throw in a third vector, then you can get what's called a parallelepiped, a parallelepiped, which is a three-dimensional analog of a parallelogram. So a parallelepiped would have 6 faces, and each face would be a parallelogram. So something like that. So it's got 6 faces, and each is a parallelogram. Okay, so how do we find the volume of this parallelogram? We have to use something called the scalar triple product of the 3 vectors. And it doesn't matter which order you put these in. You take one of them and you dot it with the cross of the other 2. Now, the scalar triple product is sensitive to the order of the cross product, but the volume of the parallelepiped is going to be, we're going to put these absolute value bars. Now, are those absolute value bars, or is that magnitude? V cross W is a vector. U is a vector dotted with a vector is a scalar, and that's why it's called the scalar triple product. We're going to just get a number inside of these vertical bars, and so these are, in fact, absolute value bars. So even if you switch the order of the vectors V and W here, you'll get the same volume. So, okay, let's compute our scalar triple product. This is just an excuse to do a cross product. And again, the most important reason for doing a cross product is to find a vector which is perpendicular to both of the ingredients in the cross product. That's extremely important in Calculus 3 when we're interested in planes. If you have a plane, then a plane is determined by, we could think of it as 3 points, but also a point and a vector perpendicular to the plane determine the plane. So we need this concept of a perpendicular vector, and that is frequently obtained by doing the cross product. Okay, so here, though, we want to do a cross product to find the volume of a parallelepiped. So V cross W. V cross W is the determinant of the matrix ijk, the unit vectors in the x, y, and z directions. And then we'll put V in row 2. That's 3, 0, negative 1 given. And W, negative 6, 2, 3. So this is I times the determinant of this 2 by 2 here, which is 0, minus negative 2, which is 2, and then minus J. We go plus, minus, plus across the first row, and then the 2 by 2 matrix removing this column and this row. 3, negative 1, negative 6, 3, that one. Let's write it. 3, negative 1, negative 6, 3. We want the determinant of this, which is 9 minus 6, which is 3. And then plus K times the determinant of this 2 by 2, which is 6 minus 0, so 6. So V cross W is the vector 2, negative 3, 6. And now we have to dot that with U. So U, which is given, dotted with V cross W, is equal to 2, negative 4, negative 5, dotted with 2, negative 3, 6. That was our V cross W. And this dot product is 4 plus negative 4 times 3 is 12 plus negative 5 times 6 is negative 30. So that plus was a little premature. 16 minus 30 is negative 14. And our volume will be the absolute value of this scalar triple product, which is the absolute value of negative 14. And that is 14.